Let's consider what's occurring at the surface of the rod as a scraper passes over it. We have here a simple illustration of the surface of a rod mounted horizontally. On the surface, we've shown in blue triangles a representation of a layer of contaminants. In reality, these contaminants are made up of individual as well as groups of particles, each capable of developing multiple types of adhesive bonds. These bonds may evolve over time from adsorption bonds, which are relatively weak, caused by the likes of van der Waals or static forces, to absorption bonds caused by comparatively strong forces such as chemical or mechanical bonds. The scraper acts as a physical barrier that simply prevents large contaminant particles from bypassing. As a scraper initially passes over the surface of the rod, it is delivering a cleaving force to the rod, breaking these various adhesive bonds. It would be naive, however, to think that all contaminants would be removed in a single pass. Depending on the strength of the bonds and the nature of the contaminant particles, residual material may remain. A further action, therefore, of the scraper is to render any residual material into a state that can be removed by a traditional wiper. This is obviously a very simplistic and stylized presentation of the surface of the rod. We're now looking at a photograph of a cross-section of an actual mechanical surface with a layer of plating apparent. In this cross-section view, we can see the topography, including various asperities, troughs, overhangs, and so on. What's also apparent is the interface between the coating and substrate of the rod. It can be seen as irregular in a similar way to that of the surface of the plating. Let's look at another view of the surface. In these overview images of the surface, this is polished chrome, we can see that there are many complex surfaces, overhangs, and crevices, each of which harbor contaminant particles. With this complex topography, it's apparent that certain types of contaminants can clump together and surround the features of the topography, and therefore gain a means of mechanical attachment. The large complex surface areas in each of these facets are ideal for exposing chemical elements as a basis of the formation of strong chemical bonds. So we'll adapt our stylized view to at least show a simple representation of this complex topography. We also know from our understanding of the nature of plating and coatings that many times they are porous and prone to micro defects, which extend to the topography below the surface. Fissures and crevasses and reservoirs can extend through the layer of plating into the substrate. All of these features in the topography provide various means of contaminant penetration, enhancing the potential for mechanical and chemical bonding, adding to the adhesive strength of these contaminants. As the scraper moves across the top of the surface, it is effectively acting as a tool, performing a polishing or a burnishing action, acting upon the peaks and asperities. Material that is dislodged from the peaks, as well as material displaced from the scraper body as a result of wear, combine to fill in troughs, cracks, and fissures. The combined effects of the removal of peaks and infill of troughs can be a measurable change in the surface finish of the rod. In some applications where a thin film of hydraulic fluid coats the rod and contributes to the performance of the various other seals and packings, this improvement in the finish also improves the coherence of the fluid film, which can produce positive benefits, including reducing the coefficient of friction, resulting in less wear and promoting improved sealing performance and longer life. The result of a scraper's burnishing action is evident in this photograph. This scraper was cycled 1,000 times at each of 7 different stroke lengths, each stroke length reducing by 1 centimeter after the completion of the target cycles. The finish of the rod has changed progressively with each set of cycles. With this, we conclude our look into the action of a scraper on a typical rod. In future modules, we'll look more on the impact of the rod geometry on the performance of the scraper and vice versa. Thank you.